Okay, so this week classes we will discuss about the topic of traveling salesman problem and vehicle routing problems. It is in particular very popular topics that is often being used as an example for classical optimization problems, well, especially combinatorial optimizations. Okay, but before we straightforward to discuss those two particular models, the TSP and VRP, we will start from a more general discussion on where this model is often being used, in which it is transportation problems or a discussion related to transportation, especially in supply chain management. And in transportations, we will have to make a decision about routing and scheduling those transportation modes that we are going to use to transport the goods. And those are modeled often as TSP and VRP. And okay, for the course outcome, so what we're focusing on is today to formulate the models. So instead of using tools and software to solve the problems, we will put that as a discussion for the next week's topic. So it will be discussing course outcome number one. Okay, as promised, we start from the bigger picture. We see how transportations take a very important role actually in the supply chain process. So well, when you talk about supply chain, right? Supply chain is the arrangement of activities from suppliers to the end customers on how they can provide the services or goods to the end customers. All those party involved are considered as one supply chain organizations. And if you still remember there are three main things being managed in supply chain. Number one, there is goods. How do you manage the flow of goods in the supply chains? The second one is that how do you manage the flow of information in supply chain, and how do you manage the financial flow in supply chains? Okay, and among those three, managing goods needs to consider the physical property of those goods being managed. To transport, to manage the flow of goods, you will need to rely on the effectiveness of your transportations. Okay, so that's why it is often said that transportation taking a vital or important roles in the supply chains, because when you some survey even said that when you break down the cost component of supply chain, transportations, logistics is often take quite a big chunk of those portions among the total cost. Okay, so it is often that the success of your supply chain or the success of your organizations in general is often linked to how your organization could appropriately use the the means of transportations. Okay, and if we talk about transportations, there are many stakeholders or many parties are involved, and these are the terms that is commonly used to represent party in supply chain. We have some called shippers, we have some called carriers, we have policy makers, we have infrastructure owner and operator. What are those? The transportation stakeholders can be categorized and defined as follow. We can say that a shipper is a party that requires the movement of products between supply chains. So it's like the product owners is often called the shipper. And when you need services to bring your goods from one point to another point, it is often you will contact a party called carrier. Okay, carrier, the one that carry your goods or move your goods. And in the transportation stakeholder, we need to also understood the power of policymaker being being a party that we hope could promote fair competitions and provide the balance between the environment, energy, and social concern of the transportations. Why? It is most often the policymaker will be the governments. So that's why when you try to make an efficient transportations choice for your company, you need to also consider the policy where do you operate. Okay, and lastly is about the infrastructure. So transportation will be heavily rely on the availability of infrastructure for those particular transportations. Well, anyway, this earlier slides is taken from the this website, ICA.org. Well, why do I choose these sources? Because me in particular is has taken the certified supply chain analyst that provide by these organizations, and I think that the way they wrap the certifications, it's quite nice, and it can give us good knowledge about how supply chain works and how it can be implemented in practice. And that's why I'm taking the certifications, and I think it's also good to provide to you guys the what is being discussed in that certifications. And one of the point being discussed is how transportation affect the supply chain. And here's some glimpse of the slide that I can put and re-delivered to you. Okay, and then about after that, transportation stakeholder. Yeah, when we talk about transportations, then we will also see that there are a lot of transportation modes available that perhaps will be that for a supply chain manager or for a decision maker, they need to really understood the characteristic of each transportation mode so that they can wisely or considerably create or make a correct decision in terms of which transportation mode will be used for their goods transportation. Okay, for example, if you are trying to transport goods that perhaps the in terms of mass, it's quite high, it's heavy, and but it's in terms of value is not very high or it's low. So perhaps you can try to find the transportations modes that suit for that type of products. For example, perhaps you can, instead of using the air transportations, because air transportation will be more expensive and it's more suitable for a high value goods. So for the type of products that I mentioned earlier, perhaps the water type will be more suitable, something like that. So it is important to understand the characteristic of transportation modes before you select which one you are going to use. And then another considerations need to be made also regarding to choose of transportation option is the understanding of the design option for the transportation networks being available for your problems. For example, when you're going to use the let's say the truckload. Truckload means that you're going to utilize full truck capacity every time you ship your products. Okay, then you need to understand why you are going to use their transportation options. And then instead of truckload, why don't you use the less than truckload, something like that? What is the basis of using those, choosing those options? Okay, and then for example, if you are using direct shipping networks, perhaps full truckload will be more suitable. But if you need to do the milk run, it means like you need to pick up or deliver goods in several locations, and the amount of location will be less than the full capacity of your trucks. So how do you deal with it? You need to reconsider again what kind of type of transportation you're going to use. Okay, another things like if your transportation networks need to involve shipment to central distribution center, okay, what should you do? Whether you use truck or you use rail transportations, okay, those are the considerations often made in the decision regarding transportation networks. Okay. Okay, lastly, before we discuss about our topic today, in the transportations problems, one particular transportation problems that is often being discussed is how to create routes and schedule the trucks for your transport for your vehicles that available. So this is considerably a complex operational problems in which it is often involve IT systems or software to be used to solve the problems. Okay, and the software or the routing and scheduling software is often used to identify the decision, such as what kind of what is the optimal routes that minimize the cost of the distribution or the cost of the operations of the truck operations. And also sometimes we also want to see the number of the trucks being needed or the fleet utilizations, something like that. Okay, and to give you a more practical context, I will play a video on one of the biggest e-commerce in the world and how they conduct their delivery operations. Okay, so because this is a YouTube video, so I will stop the recording first and then play the video to you, and then we can start the discussion again. But for now, let me stop it first. Okay. Well, okay. So basically, yeah, despite the controversy mentioned in the video, in this 25 minutes video, it's really grabs the whole pictures on how an e-commerce, well, in this case Amazon, operates in general, right? There is so many decision involved there, and one particular operations in which we call it a last mile delivery is one of the important part of the operations for e-commerce business, because they need, well, the product will not deliver itself to your doors if you don't deliver it, right? So okay, so yeah, if you are still interested on the video, you can take a look again. And well, actually there is a lot of things that you can explore there if you are interested on finding some research topic. Okay, so let's talk about the how it's would relate with the VRP that we are going to discuss soon. So in a VRP case, it can be seen from a company that handle delivery or activity that's similar to the last mile logistics in which discussed earlier. So this activity is often either conducted by e-commerce entity or third-party logistics such as DHL, FedEx, or a smaller party that consider the delivery. And well, in this type of operations, we will have a number of customer location point that is need to be visited, and the number can be thousands, hundred or thousands. Well, let's say if your company have limited number of trucks or vehicles or drivers, you need to create a decisions that for each truck you will need to assign which customer and which in which sequence they will be visited by that particular trucks. And the whole plan is to that you should create the decisions or the routes that minimize the total cost, or sometimes we can call it maximize the efficiency in terms of times and capacity utilizations. So how could we manage that, right? So this question is often modeled in terms of the modeling perspective. It is called the vehicle routing problems models. So even though it's popular, it is yet a difficult melt optimization problem to solve. So especially when you consider a real case problem. For example, a real case problem might involve many complexity, such as the number of vehicle, the number of capacity will be different from one truck to another trucks, and there are multiple type of product being considered. There are time windows, in which means that some customer can only be visited at certain time only. Okay, and you also may need to consider multiple depot. Okay, even up until a real or very dynamic situation such as traffic and road congestion also often considered in the embedded in the VRP model. But despite its difficulty, when you able to solve the problems, the VRP problem efficiently, the company will be rewarded with several potential benefits, such as reduce in terms of transportation costs, increase in terms of vehicle utilization, or increase in terms of customer satisfaction. So those are the VRP in general. But when you talk about more specific topics, when you use the perspective of a researchers, VRP topic has also been studied in many different how to say, many different approach, or has been modeled in many different ways. It really due to its practicality, there is so many variants of VRP. Okay, so this is the study of VRP family, VRP variants that conducted in 2020. So it's lists almost most of the known VRP variants, even though that's, of course, there will be several lesser known VRP variants that cannot be listed here. Okay, so so the class of VRP, it consists from the basic one. For example, the most popular one, or the base, is considerably known as capacitated vehicle routing problem, or CVRP. Even until the latest one that most often consider the recent use of new technology, such as electric vehicle and drone, like mentioned in the video, is mostly already been studied in the or at least started being proposed in the literature. Okay, so when you choose a topic related to VRP, or if you somehow feel the problem that you are working on related to VRP type of problems, it means that when you create a routing decision, you want to minimize the cost or anything related to those type of problems, you can always, it's always good idea to start do the literature review first, because this topic is very popular. Most often you will find some related topic or some related paper to the problems that you are going to work on. Okay, so that's basically the idea of showing this slide to you. Okay, next, this is the illustrations. So since we talk about TSP and VRP, I will start from the illustration of TSP. So in TSP, the goal is to find the shortest possible routes, or we consider the minimum travel distance for the traveler to visit all the city, in which each city can only be visited once, and there is no subtour, or you cannot return to the previous city that you already visit. And at the end of the tour, you need to visit the origin city that you already, that is the first city you visit. Okay, you should come back to the first city that you visit. Okay, so this is the basic of VRP. So before it can be said that when you have a VRP with one vehicle, you can say that it is a TSP problem. Okay, and actually I try to find a good demo about this one. Let me see if I can open this. Okay, so wait. Let me copy. this one. Okay. Okay. Okay, this demo is supported by Gurobi. I think you should already quite familiar that Gurobi is one of the solver that we often use to select as a solver for our AMPL programming language. And for example, if you have several city here, let's say you want to select this city, okay, here are several city that need to be visited by a traveler here, denoted by oranges. Okay, now the TSP problem is the aim of TSP problem is to find the routes in which how the traveler will which city will be visited first, and then second, and then third. It's like the sequence of the city being visited by the traveler, so that the total travel cost will be minimized, right? So perhaps they can start from Philadelphia here, go to Washington, then go to Knoxville, go to Atlanta, go to Jackson, go to Austin, and so on and so on, and go back at the end of the day, go to Philadelphia. Okay, but is that the minimum total travel cost? We're not sure, right? That's why we need to find it. Okay, that's what we want to find. Okay, and by model it as a TSP problem, you can solve it directly, and then you can get those the minimum total distance and the associated routes. Okay, and for this one, I think we just need to select this optimize. Okay, so here you can see that the shortest travel routes is here with the, I don't know, the total solution is this one. So this is the distance, I guess. Okay. Okay, so that's just a demo. Of course, we will not create a website like this, but we will study how the models or mathematical models behind those that can work like this one. Okay, next. Yeah. So the formulation of TSP model actually is quite simple. I take this model from these references. So if you are interested on the detailed explanation, you can always go to the paper. So in TSP models, you first need to define a set of node n's, and then the data that is needed is the distance between each particular node, right? Because you want to minimize this one. And the decision variable is this one, xij, and there is additional variables u, in which here ui and uj, it's element n, both of them. It's to create some constraint called subtour eliminations. Okay, what is subtour elimination? It's basically that a constraint that will help you to make the routes whenever you already go from one nodes to another nodes. It will not allow you to go back to that particular nodes to create a subtour like this one. Okay, that is subtour elimination constraint. And of course, there is a mathematical explanation about that. You can check in the journal if you want. But for now, what we are going to achieve, what I want you to achieve is that at least you understood what is the meaning of all of this constraint. Okay. First, this one, the objective is to minimize. Minimize what? Cij is the cost, in which here is the distance. And then xij is whether you travel from that particular node or not. okay, for that particular arc or not. So when you have the total cost multiplied by arc you traveled, so this will be the total travel distance by the traveler that is modeled as the TSP. Okay, and then here the first constraint, yeah, this first and the second constraint is, well, it's basically just to ensure that whenever you go in a particular nodes, you should go also out from that particular nodes. Okay, so wait a moment, please pardon me, I have a cough. Please wait a moment. Okay, sorry for the interruption. So okay, so basically these two constraints, constraint number 2 and constraint number 3, is to show you that for whenever you have nodes going in here, you should also going out here. Okay, and there should only one nodes and only one arc being used going in and going out. Okay, so for example, there will, you can have several connection go to one nodes, right? One particular nodes. But whenever you choose to select one nodes here, the other nodes cannot be selected. Okay, that's why the total sigma should be equal to 1. Okay, and then for the exit node, it's also the same. You may also have several node exit from one nodes, right? And for each particular node, you need to make sure that only one node, only one arc is being selected. So whenever you already have one here, you cannot have the value is equal 1 in the another arc, something like that. So that's the that's the definitions of these two constraints. And for this one, I think there is an explanation about how this formula works in the paper here. But basically, this was the subtour elimination constraint, in which that makes sure whenever you have already route being made like this, you will not make another subtour like this that make it return to. So this is one tour, right? This is one tour already. So this is called subtour. To avoid these conditions, you need to involve this constraint. Okay. And then, so the last one is just to make sure the value of ui and uj greater than equal 0. Okay. So, okay, this is one example of TSP problem. Sometimes you will find the problems represent like this. So you have the point 1 and then the coordinate in the Cartesian coordinate form, or sometimes in longitude and latitude, right? So for example, 78, 69 is located here, or sometimes it's longitude something, latitude something, located somewhere in the maps. So from this one, normally you need to find the something's called like this, the distance matrix. So from node 1 to node 2, what is the distance here? Okay, for this one you may use the Euclidean distance. For example, it will be equal square root of x1 min x2 square plus y1 min y2 square, like that. Then you get this value of distance metric. And sometimes you directly have the representation like this. It's a graph, and this represents the distance from one nodes to another nodes, and you can directly create this, the distance matrix. Okay, but well, after that, after you know the problems, you know how to interpret the data, then you can start using the tools that we already learned earlier. You need to translate the model into term of mathematical formulation like this. Okay. Well, basically, again, the way I can easily explain to you is that for each of these constraints, you just need to map it again back here, back to this one. For example, if you want to see how do we write minimize sigma and sigma like this. See, you can see it here. Minimize. This is sum and this is sum. So 2 times you write the sums. Here is some I, here is some j. Okay, Cij, Xij. Okay, so that's how you can understood the model easier from this mathematical model. Okay, and the data. So in particular here we need the value of the set, and then the value for C, in which the represent the distance from one node to another node. That's why earlier I told you that you need to create this type of matrix, which is often called the distance matrix. Okay. Then like what we normally do, we just need to try it and solve it in MPOL. Put this one, the model, put this one, the data, and then try to solve it. You can get the result. Okay. Okay, I hope TSP is quite straightforward for you. Again, for today's classes, my concern is just to help you to get the basic idea, know the models, and then for the exploration on how the model works, and then how do you implement these AMPL programs. I think I will leave that part to you for practice. Okay. Next is the VRP. For VRP, basically, as you can see in the illustrations, when you have more than one vehicles, okay, and then you have the origin point is fixed, it is called the depot. Then you need to create the same consideration with TSP. You need to visit all the customer, in which each customer has their own demand, right? Demand, let's say here is 10, here is 20. Then you need to make the routes that also comply that you need to consider the vehicle capacity, so that all the routes that you serve should be within the capacity of the vehicle. For example, if you need to pick up 10, 20, 10 here, the total route is 60, right? 20, 10, 20, 10. So 60 total demand, but you only have 50 in capacity. So this is not a feasible route. So the model will not allow you to do that. Instead, you will either create another routes for the one that not yet being served, or well, if it is mathematical model, normally it will not give you this kind of routes. Like this can, if it is 10, then it's possible to give this one. Okay. Okay. Well, I have no demo for this one. Couldn't find it. So let's just continue to discuss about the model. For the models, okay, it is basically since it is a improvement or extension of TSP model, so you can see similarities here. As you can see here, we still have the same input here, but now we have number of vehicle capacity, demand in each customer. And the decision variable is still the same, yeah. But now for the constraint, there is several additional constraints involved. For this one, it's still the same, right? Objective and then constraint 2 and 3. But here, this is still the same. But here you see, since we have limited number of vehicles, so the routes being created also limited by this number of vehicles. So you cannot create more routes than the number of vehicles you have. And then here, this DI, UI, this is I, small I actually. UI less than cap. It means that all the, I think this is, should have sigma. Okay, let me check again with this constraint, but I think this should be the constraint related to the capacity constraint, but I'm not sure this one is correct. Let me check with you. Okay, and then you can continue to work on the models like this. Okay, here you go. And then here is the model part, here is the data part. And yeah, then you can try to run it in the ample models to see how it runs. And then, okay, up until that, well, actually, what we learned today is only the first part of how we can solve TSP and VRP. For TSP and VRP, it is considered as in complexity theory, it is considered as an NP-hard problems. So what is NP-hard problems? Later I will explain it to you. That's a discussion for next week. But basically, problems that belong to NP-hard problems is often to be difficult to solve using exact solution. Okay, so that's why we need to understood or study another way to solve this type of problems, so that the result that that is generated, or the solutions being provided by this approach can be used to solve a larger size of problems for these VRP and TSP problems. Okay, and the illustration is like this. For example, if you have a TSP problem with 5 nodes, okay, to consider all the possible solution for a VRP with 5 nodes, we can estimate it using this estimation, which is n factorial. Okay, it is come from like this. For example, if you have 5 nodes, okay, so the way you can find the combination between these 5 is actually 5 multiplied by 4 multiplied by 4, 3 multiplied by 3, 2 multiplied by 1. So it is 5 factorial, something like that, right? So that's why now when we see the more number of nodes being considered in the TSP problems, the more solutions, possible solution it is available. And exact solutions tend to explore almost all of those possible solutions. Okay, almost all, not all, but mostly they will try to explore many part of these solutions. Okay, so the more the growing the number of the nodes, the more possible solution is available, the more difficult exact solution will find the result. Okay, yeah, that's why when it's a complex problem or an NP-hard problems, it is often consider a heuristic and meta heuristics approach, because whenever the problem size is growing here and the possible number of solutions is getting more and more, so these two type of solutions will give you a mechanisms to somehow shorten the searching time of finding a good solution among these many possible solutions. Okay, so that's why we will learn this one after the midterms. It is we will of course study this after the midterms, and but to study heuristic and meta heuristic, since it is an algorithms, it is a little bit more considerably have different implementation than the exact solution that we often used earlier, in which we just put it in a mathematical formulation and then solve it, and then let the solver find which exact solution approach they were using. But for this one, we are going to somehow code it manually. So we code by ourselves. So perhaps you, after the midterms, you may want to take a look basic programming language, and then try to start study about it before we, because in the class I will have no time to teach you again basic programming language. Okay, so I think that's for the introduction about TSP and VRP for today. Okay, up until here, I think, do you have any questions that you want to discuss?